Hey there guys, welcome to the notes videos for lesson 2.2. We're still working with absolute value transformations. This is our second day dealing with transformations. And today we're going to be working more on paper and seeing more what's going on to these transformations beyond being able to name them. So what we're going to start with is that we see I'm given my parent function, absolute value of x, and my transformation function, negative absolute value of x. So first, we need to find our value tables by seeing, okay, what's changing in this case. So I see if I plug in a -4 into this, well, absolute value of -4 is +4, but notice how the negative is outside of that absolute value bar. So this is telling me whatever happens after I take the absolute value of it, make it negative. So first off, for my parent function, I'm getting a little ahead of myself. For my parent function, just going into the regular absolute value bar, -4, absolute value of -4 is just +4. Absolute value bar to make anything negative positive. -2 absolute value is +2. Absolute value of 0 is 0. Absolute value of 2 is 2. And absolute value of 4 is 4. Now in this case with our transformations, I'll use the exact same number. So let's use a -4, -2, 0, 2, and 4. So like we said before, I'm going to plug in the -4, and while normally this would give me a +4 back, since there's this negative right here in the front, my +4 is going to turn back to a -4. Same thing if I plug in my -2 into this equation, well, absolute value of -2 is +2, but then I have to make it negative. 0 can neither be positive nor negative, so it's just going to be 0. Absolute value of 2 is 2, but make it negative. And absolute value of 4 is 4, but make it negative. So I'm going to plot my original points. My original points were -4, 4, 1, 2, 3, 4, 1, 2, 3, 4, -2, 2, 0, 0, 2, 2, and 4, 4. Which creates my absolute value parent function, which is just that V shape. So connect your points, and then remember when we're connecting points, don't just connect into the points you've drawn, make them go all the way because they extend on infinitely. So for my absolute value parent function, what I can see is going on is now I have -4, -4, 1, 2, 3, 4. -2, -2. I still have 0, 0. 2, -2, and 4, -4. So this time what's going on the other end is that I can see, oop, that wasn't a perfect connection, but that's fine. I can see that my absolute value bar kind of got flipped. It is now going upside down, which is what we know. This is a reflection. So remember, since this is a reflection, that means that I'm going to reflect about the x-axis. So what is on top will kind of be copied over as a reflection on bottom, which is what ended up happening. Similarly here, I have my parent function, absolute value of x. So it's going to turn everything positive. So 4, 2, 0, 2, 4. And what I can see happening here is that I have a -4 on the outside. So whatever I take the absolute value of, I then need to subtract 4 from it. So if I plug in my x value, -4, into here, absolute value of -4 is +4, but 4 minus 4 is 0. And by the way, I'm still going to use my -4, -2, 0, 2, and 4. -2, the absolute value of -2 is +2, minus 4 is -2. Absolute value of 0, 0, minus 4 is -4. 2, absolute value of 2 is 2, minus 4 is -2. And absolute value of 4 is 4, minus 4 is 0. So let's start plotting these graphs. So I still have 0, 0, -2, 2, and -4, 4. 2, 1, 2, 2, and 2, 3, 4, 1, 2, 3, 4. So I still have my parent function right here. So nothing has changed so far for the blue graph. But now that I look at my green graph, I can see that, okay, negative 4, 0. I'm going to have a point right here. And then negative 2, negative 2. So negative 2, negative 1, 2, 2. 0, negative 4, 2, 3, 4. 2, negative 2. And 4, 0. So my transformation function looks like this. Now, hopefully, just by looking at this part here, you can notice that this is a vertical translation. In fact, we should be going down 4. And in fact, if I look at my graph, you can see that, oh, that is what's happening. I am going down 4. So all my original points got shifted 4 spaces downwards. So let's start with our parent function again. Absolute value functions make everything positive. Let me graph this real quick. 0, 0, 2, 2, 4, 4, negative 2, 2, negative 4, 4. So here's my regular parent function, absolute value of x. Where I'm extending my lines going all the way, not just stopping at my last point. And I'm going to use the exact same points. Negative 4, negative 2, 0, 2, and 4. This time I can notice what's going on is that I have an addition or subtraction inside. So first off, addition and subtraction lets me know it's a transformation or a translation. And since it's inside the parentheses, I know that I have a horizontal translation. Now, if you remember, when you're inside the parentheses, it's opposite. So although this is positive, this should be going left 4. But let's see if that's what's actually going on. So inside the parentheses, negative 4 plus 4 is 0. Absolute value of 0 is 0. Negative 2 inside the absolute value bars. So negative 2 plus 4 is 2, and absolute value of 2 is 2. 0 plus 4 is 4, absolute value of 4 is 4. 2 plus 4 is 6, and absolute value of 4 is 6. And then 4 plus 4 is 8, absolute value of 8 is 8. So let's try to plot these points. Negative 4, 0, 1, 2, 3, 4, right here. Negative 2, 2, 1, 2, 1, 2. 0, 4, 1, 2, 3, 4, 2, 6, 2, 4, 5, 6, and then 4, 8, 6, 7, 8. Now you might be saying, hey, what happened to my V shape this time? Well, we didn't choose the correct point, so we're missing the other half of my V. But I can figure out what it's going to be because everything is going to go left 4. So this point here, negative 2, 2, is now going to go left 4, so it's going to become negative 6, 2. 4, 5, 6, 1, 2. This point here is negative 4, 4. It's going to go left 4, so negative 8. So 6, 7, 8, 4, 1, 2, 3, 4. Right here. And you might say, okay, where'd you get those values? All I did was added 4 to my x values. So we can see what's going on is that my graph is going to the left. I have my same graph, just shifted 4 points or 4 units to the left. And then we'll see what an example of this looks like with a stretch or compression, which we know this is stretch and compression because there is no adding or subtracting, nor any negatives for reflections. It's outside my absolute value bars, which lets me know it's a vertical stretch or compression. And since I'm outside the absolute value bars, what it looks like is what it is. So if it looks like it's a bigger number, it's going to get bigger. So it's bigger than 1. So this is a vertical stretch. So we know we have a vertical stretch by a factor of 2. So first off, let's put in my original values. My original graph, same thing as before, everything will become positive. Here, let's use -4, -2, 0, 2, 4. I'm going to plug in -4 into my absolute value bar. The absolute value of -4 is +4 times 2 is +8. Absolute value of -2 is +2 times 2 is 4. 0 times anything is 0. Absolute value of 2 is 2 times 2 is 4. And absolute value of 4 is 4 times 2 is 8. So my original function 0, 0, 2, 2, 4, 4. -2, 2. -4, 4. So here is my original parent function once again, just the absolute value of x, with no transformations, no compressions, no translations, no reflections. And we're going to see what's going on to my graph. So I can see that I have a -4, 8. So -4, 8. So this is 4, 5, 6, 7, 8. -2, 4, 2, 3, 4. 0, 0. 2, 4, 1, 2. And 4, 8. 4, 5, 6, 7, 8. So now when I connect my points, what I can see is that I didn't move left, I didn't move up, down, there's no reflection. It looks like I just got skinnier because I'm stretching it out. I'm pulling it out. So I did, in fact, change. And another way you can check to see, your parent function is always going to have a slope of 1 over 1. So here we can see I can go up 1 over 1. And then let me zoom in a little bit more. If I look at my new function, if I have a vertical stretch by a factor of 4, that means my slope needs to be 2. So up 1, 2 over 1. Up 1, 2 over 1. Up 1, 2 over 1. So we can see that my new green graph has a slope of 2. So that's just how to graph functions given a transformation. But let's go back into writing our equations. Now, generally when I write equations, what I like to do is I just like to write g of x for my transformation is equal to, leave space in the front, absolute value, leave a little bit space in front of x in case there's a horizontal stretch or compression. Just do this. And I'll put in things where they go. So a function is reflected about the x-axis. So I have a reflection, so I know there's going to be a negative somewhere. And if it's reflected about the x-axis, if you look at your chart in the beginning of your packet on page 3, you can see that means there's a negative in front of the absolute value bars. Vertically compressed by a factor of 0.3. Vertically means, once again, it's outside of the absolute value bars. And then shifted left 4 units. So 3 things are going on here. So there needs to be three things that I have written here. So first and foremost, I'm reflected about the x-axis, so I need a 0 or a negative. And to be careful, compressed, its own number. So a reflection and a compression are two different things that are happening. The negative tells me I'm reflecting, and the 0.3 tells me I have a compression. And remember, if it's vertical, it means it's outside the absolute value bars. And if it's not adding, subtracting, it should go in front of the x or before the x. Same thing with the reflections. Then I'm going left 4. Left 4 is a horizontal movement. It's going from left to right, which means I should be inside my absolute value bars. And I'm going left 4, which remember, if I'm inside the absolute value bars, it means it should be opposite. Now feel free to go back to your notes and use this right here. So we can see that, okay, if I'm going left, well, left means I have to have a plus inside. Reflection about the x-axis means I need to have a negative outside. And a compression means I need to have a number in front of the absolute value. So if you can't go straight to this, that is okay. Same thing here. I'm going to generally just write g of x, leave space in the front, absolute value, leave a little bit in front of x, absolute value. So let's see what's going on here. The function is stretched horizontally. Anytime I see any horizontal transformation, that means I am inside the parentheses, or inside the absolute value bars. And then translated 10 units down. So 10 units down means it's going up and down, which is vertical, which means I should be outside my absolute value bars. And down means to subtract, so it's going to be minus 10 outside. Now be careful, these aren't ones, these are my absolute value bars. And then horizontally stretched, which means, remember, if you have stretch or compression, it's in front of the x, but if it's horizontally, it's in front of the x and inside my absolute value bars. So by a factor of 2. So this is my horizontal stretch by a factor of 2. But remember, it's opposite what's inside, so I actually have to put in my reciprocal. And once again, you can go to your chart. Horizontal stretch by a factor of 3 actually means you have the reciprocal, a 1/3, because it's opposite. So be careful about that one. That one's the tricky one. Last one. G of x, leave a little space, leave a little space, leave a little space. The function is reflection about the x-axis. We have another reflection. So that means I'm going to have a negative. Vertically stretched by a factor of a. Vertically, which means it's outside the absolute value bars. And then translated c units right. So I have a negative because of the reflection. Vertically stretched, oops, highlighted the wrong thing. Vertically stretched by a factor of a. So since there's no number, I'm just going to put negative a. Remember, since it's vertical, it's going to be outside my parentheses, and then translated c units to the right. So inside my parentheses, it's going to be opposite. So I'm going to do minus c. And remember, if you are struggling, you can always write it like this. So now we're going into describing graph transformations and equations. So first off, we're going to graph it, and then we are going to see what it looks like and describe my vertical description. So we always start 0, 0 if we're thinking about my origin. So first off, you always have to do stretches and compressions first. Something that is a good saying to kind of follow. You have to stretch before you run. So before we do any type of translations, going up, down, left, or right, doing reflections, we have to think about our stretches. So I'm going to use a pencil or my erasable pen, because this will be a work in progress. Especially when you're graphing them with multiple transformations, I highly suggest using a pen or pencil. So we see that I have 2/3. So that means my point has to go up 2 over 3. 1, 2, 3. One, two, right here. So generally here. Now, I'm not going to leave this point here because that is what's going to happen with my vertical compression. But then I have to go left 4, down 3. And if you still have to use your chart, that is okay. So this point is going to go down 3. One, 2, 3, right here. But it's also going to have to go left 4. 1, 2, 3, 4. So we're finally where we want to be. So I'm going to erase everything else. And this is why I said make sure you have something erasable, because it's going to be quite a work in progress. So we're going to do the same thing. From the point that I had here, I'm going to go up 2 again, 1, 2, and over 3 again, 1, 2, 3. So this is the point I'm going to be moving around. So this is the point I'll be going down 3 and left 4 with. So down 3, 1, 2, 3, and left 1, 2, 1, 2, 3, 4. So I can see I'm going to start making a connection here with these 2 blue points. 0, 0 is just going to be 0, 0. So to move 0, 0, I'm going to go left 4 and down 3. 1, 2, 3, 4, and down 1, 2, 3. I can also go up to left 3. And the 2 and 3 are the compression from here, so that's where I'm getting this point from my original parent function. And then we are going to go down 3, 1, 2, 3, left 1, 2, 3, 4. Once you have enough points where you can start to see your V shape, you can connect them from there. So I can see that, hey, let me make my V shape. So this is my transformation function. So we're going to put our verbal description, which we kind of already said. We have a vertical stretch by a factor of 2/3. We go left 4 and down 3. And also, since this is 2/3, it's not a vertical stretch, it's a vertical compression, since it is between 0 and 1. So now we're going to go here. A lot's going on. So generally my vertex is the first point, 0, 0, that I like to deal with because it's easiest. 0 will become negative, but that's fine because positive and negative 0 is the same thing. And then doing a compression of 1/3, well, 0 times 1/3 is 0. So I know my vertex is going to stay. So I'm not moving left, down, left, or right. So We're still staying here. Now, my horizontal stretch tells me I'm going up 1 and over 1, 2, 3. But the reflection is telling me to make it negative. Same thing, go up 1, over 1, 2, 3. Same thing, but make it negative. So this number except negative 2. I can do the same thing on the other side. Up 1, left 1, 2, 3. Same thing, but negative 1. Up 1, 1, 2, 3. Same thing, but negative 2. Once I have my V shape, I can connect it. This is my transformation function. And the pink was just my original reference points. So once again, you're going to need them to erase because multiple transformations are going on. So you're going to be moving up, down, left, right, so on and so forth. Similar to how you did in Delta Math. Now this one is quite the transformation. So before we get there, let's write our descriptions. So we have a reflection, but don't just tell me it's a reflection. It's a reflection about the x-axis. And a vertical or horizontal stretch by a factor of 3. Remember, inside the parentheses or inside the absolute value bars is opposite. So in this case, the 1/3 is going to become a 3, and although it's small, it's going to be called a stretch. So we'll skip number 3, just in general. That's too many transformations. It's 1, 2, 3, 4. And we'll go to example 4. So for example 4, we have to write the equation for g of x obtained by performing the given transformations on f of x, which just means our parent function. So we have a parent function, f of x equals absolute value of x. So we need to write the equations from function notation to absolute value. So you might have noticed sometimes you have parentheses and sometimes you have the absolute value bars. So all we have to do is where there's an f of x, it's going to get changed into, so the f of x will get changed into absolute value bars. And everything else will stay the same. X, negative, g of x. Same thing here. My f parentheses, my n parentheses, these will change into absolute value bars, and everything else will stay the same. Hopefully you get the idea. The f and the parentheses will become my absolute value bars, and everything else will stay the same. So these, hopefully, after seeing relatively hard graphing transformations, now be careful when there's multiple parentheses. You have to figure out which parentheses close the f of x. In which case it was this. So even if there's multiple transformations, still just do the same thing. The f of x, or the f parentheses will just become your absolute value bars. And then you bring down whatever is in there. So if there's an x minus 3, bring down the x minus 3, a plus x on the outside, a negative on the outside, bring that all down. Same thing here. And if On the converse, if it's very simple and there's only an x on the inside and then only a 6 on the outside, it'll stay the same. So that's how to go from function notation to absolute value notation. And they'll mean the same thing. This function notation is still talking about a vertical compression because it's outside. This one's talking about a vertical stretch because it's outside but it's bigger than 1. This one we're going right 3 and up 6. So they have the same description. This one is just saying, hey, specifically in the shape of an absolute value graph. This is just in general, just general transformation. So that's it for your notes. So make sure to do your practice in your packet.